Hey guys, so today we'll be doing Leetcode 1 Two Sum. So we're given an array of integers nums and an integer target. We need to return the indices of two numbers such that they add up to target. We may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So there are actually two approaches to do this: the brute force approach and the complement approach. So and I will explain both. But first, let's take a look at the examples we have. So we can see that we're given this um, array, nums array, and we're given a target. So we need to return the index 0 and 1 because 2 plus 7 equals to 9. They add up to 9, and we return those indices. Let's get another one, similar case. So in this case, it's 1 and 2. 2 and 4 add up to 6. Um, and the constraints are 10 to the fourth. So O of n will work here. O of n squared solution will work here. And we see that the follow-up is, can you come up with an algorithm that is less than n squared time complexity? So what we can think of doing when we see these numbers, right? So 2, 7, 11, 15. Your first thought might be, okay, I'll just loop through everything twice, and if I see that they add up to a target, I'll return that. And that's exactly what the brute force approach is. So I'll use I and j for the variables. Actually, before that, let me specify that how many elements do we have. So let n be the number of elements in the array nums. So for I in range n, and then for j in range n, and then we'll try to make sure that it is not the same element. As you can see here, you may not use the same element twice. So we can simply say if I not equals to j. We could write another if statement here, but to keep it simple, I'll just do another and condition. And we can say nums I plus nums j equal to the target. If so, we return I and j. The order doesn't matter, so we don't need to worry about that. And this will pass. I'll run it to make sure. Yeah. But this is not the best solution because, as you can see, this uses two loops. This will process each element at most twice, two times. And that's not ideal for this problem. Now for the complement approach. In this one, we'll use the complement logic. For example, let's take this. So x plus y equals to 0, right? Now, essentially what this is saying is, hey, if you have 1 plus 3 equals to 4, then 4 minus 3 equals to 1 must also be true. And 4 minus 1 equals to 3 must also be true. I don't know if I just said the same thing, two things twice, same thing twice, but yeah, that's the idea for this. Essentially, hey, if we know like two numbers, this one and this one, we can predict the third number if we have already seen it, or like we might see it, like that kind of idea. I think it'll make more sense if I just show. So we'll need to keep track of the elements we have seen. Um, so it could be like this. Let me show with an actual example. So 2, 7, 11, 15. So actually, that's kind of a bad example because the answers are right up there. So let's take 3, 2, 4, and then our target is 6. So we'll say, hey, have you seen a 6 minus 3 before? We have not. Hey, have you seen a 6 minus 2 before? A 4. We have not. And then we'll say, hey, have you seen a 6 minus 4 before? We have. So we'll return that index and the current index we're at. So that can look something like this. So I'll store it in a complement map, and then we need to loop through the elements. Now we check what is our complement. Target minus nums I. Now we're gonna check. Hey, if um, if complement in comp map, that basically means we have found the third number. So, for example, let's say our numbers were 3, 2, 4, and then the target was 6. Let's say our complement is, in this case, 2. Our target was 6, and we're currently at 4. Complement is 2. We have seen 2 before, and we stored it in the map with the like this. We stored it with the position. It's at position 1. So now we're going to return the current position, and since the order doesn't matter, it won't matter whether it's before or after. You don't have to worry about the sorting. And where is it in the array? So we'll get the value from the complement map of the complement, and this should also work. And then I'm just going to comment this out. Oh, comp map. Oh, so so if this is not true, we also need to add the elements to the complement map, and this needs to be empty. Silly mistake. Um, so now we simply add the element, so the value. Hey, we didn't find anything in the complement map, so we add the value and where the value was found at to the map, in case we find this as a complement later in the future. And as you can see, that passed. Uh, so this is a O of n solution because we only process each element once. And I'll run it again. Awesome.